Okay. Well, welcome back, everyone. We've been talking about cohort study designs, and just remember what a cohort study design entails. You enroll people in a study who are at risk for developing some outcome. You classify them as being exposed or non-exposed, smokers, non-smokers. You follow them forwards in time, and you measure outcomes. Who develops heart disease and who doesn't develop heart disease. Well, let's just talk a little bit more about this follow-up period and the notion of being at risk. And what I'd like you to do is let's think about doing a study where you want to look at the effect of radiation on the risk of developing a cancer like leukemia. So you enroll people who some of them were exposed to radiation for one reason or another, therapy or accident or something like that. And you have some people who are not enrolled, not exposed to radiation, and you're following people forwards in time. But let's focus on the people who were exposed to radiation. If they developed leukemia a day later after the exposure, it would be hard to argue that that leukemia could be caused by the radiation. Even though they're at risk of developing leukemia, the question I'd like you to think about right now is being at risk for developing the outcome, leukemia, because of the exposure to radiation. And there are two periods of time during the follow-up period for which you might question whether any case that develops during those periods of time might not be caused by the exposure itself, even though it's happening among exposed people. So what I'd like to introduce is the notion of two time periods that are part of the follow-up period. One is known as the induction period. It's a period in time between when the exposure happens and when the disease actually occurs. So again, if you're thinking about people who were exposed to radiation, the period of follow-up begins at the point of radiation exposure and goes into the future. But the development of leukemia occurs sometime during that period of time. The period of time between the exposure and the development of disease is what we call the induction period. So let's, for example, think that it takes 3 years for the mechanism by which radiation is going to cause leukemia to actually cause the disease to occur in an individual. That's what the induction period refers to. The time from exposure, when a person's first at risk, until the time in which the first malignancy of a cell happens, when a person really does have a disease, has developed leukemia. We might not be able to detect it at that time, but the disease does exist in that person. Now the problem is we don't know these induction periods. For some exposures, the induction period can be almost instantaneous. If I shot you in the chest with a bullet, it's going to cause heart disease instantaneously. The disease occurs a second or a nanosecond after the exposure happens, after the bullet is shot. But for something like leukemia, it might take years until the harm due to radiation actually manifests in the development of disease. But there's another problem on top of that. I might have leukemia due to the fact that I was exposed to radiation 3 years ago, but medicine doesn't have the technology for detecting that leukemia yet. The testing mechanisms that we go through to identify a case of leukemia might take another period of time, and that's what is known as the latent period. It's a period of time between the disease actually does exist in an individual and the time in which we have the technology for declaring that it's existing, for detecting it in an individual. Both of these periods cause the same problem to we epidemiologists, as I'll explain in a minute, and sometimes they're combined into this notion of an empirical latent period. But let me try to explain that a little bit more in a picture. Let's suppose again think about radiation as your exposure, leukemia as your outcome. There's a point in time when a person is exposed to radiation. And then a person's going to be followed over time to see if they develop this outcome, leukemia. They are at risk for developing leukemia any time during that follow-up period. What I want you to think about is, are they at risk for developing leukemia because of their radiation? During the induction period, the time that the radiation begins, up until the time a disease might develop in an individual, any case of disease that happens during that follow-up period, during the induction period, probably cannot be blamed on radiation. It has to be blamed on something that happened prior to the radiation. So even though an event has occurred, We can't essentially argue that it was caused by the exposure of interest. The same thing during the latent period, the time period again between the existence of a disease in an individual and the ability to detect that disease by current medical technology. Any disease that is detected at that time either existed prior to that time during some induction period, or might have existed prior to the actual exposure to the radiation. So the problem to we epidemiologists is, as we measure person time, what do we do with the person time and the events that happen among exposed people during a period of time when you can argue that it could not have been caused by the exposure? So here's a diagram which we looked at before, just displaying the relationship between an exposure and an outcome in a cohort study. This is a closed cohort study. Everyone's followed for a fixed period of time, either until they develop the disease or the disease ends. So each arrow is a different person. Each arrow ends with the development of disease, that's what these little X's refer to, or ends when the study ends. Now what I've done is I've shaded the first part of this follow-up time to represent that induction period and that latent period. The time period during the follow-up where any event that happens among the exposed people was probably not caused by the exposure. And the question is, what do we do with that, especially among the exposed person's follow-up times and their exposed events? If we're trying to measure the true effect of the exposure on the outcome, if we're trying to measure the effect of radiation on leukemia, it's hard for us to use this follow-up time and the events that happen during this shaded box, during the induction period or the latent period, and say that follow-up and those events were caused by the radiation. So what are we going to do when we have this problem? The problem, again, is that all these outcomes and their follow-up time that happen during this period, the induction period or the latent period, cannot be blamed on the exposure. The exposed subjects, essentially, although we're at risk of developing disease during those periods, we're not at risk to developing disease due to the exposure. That's the problem. That person time and those outcomes essentially are reflecting non-exposed person time and outcomes that happen among non-exposed person times. So what can we do to essentially resolve this problem? Well, we don't want to assign it to the exposed people, because that person time and those outcomes are not reflecting the effect of the exposure, radiation, on the development of the outcome. Probably the best thing to do is to eliminate such outcomes and their follow-up times from the study. We're going to begin the follow-up period 5 years after the radiation exposure. So all the person time, all the events that happen among the exposed group can be attributed to people who are at risk of developing disease due to their exposure, due to their radiation. Or if we want, we could count that period of time during the induction period or during the latent period as person time and events out of person time that essentially are blamed not on the exposure, as if they were non-exposed people contributing those times. Conceptually, those are the options we have. The problem is we don't know the time period, the length of the induction period, the length of the latent period. We don't know whether it's 3 years or 5 years. We might be fairly confident that it's not, the effect of the exposure is not instantaneous, that radiation takes time to cause harm in a person that might lead to leukemia, but we don't know how long. So a conservative approach would be to eliminate perhaps some of the early period of follow-up,